Asymmetric encryption algorithm. What is asymmetric encryption algorithm? The data encryption standard algorithm is a symmetric key block cipher created in the early 1970s by an IBM team and adopted by the National Institute of Standards and Technology, NIST. The algorithm takes the plain text and 64-bit blocks and converts them into ciphertext using 48-bit keys. Since it's a symmetric key algorithm, it employs the same key in both encrypting and decrypting the data. If it were an asymmetrical algorithm, it would use different keys for encryption and decryption. Because the data encryption standard, DES, has been discovered to be vulnerable to extremely powerful attacks, its popularity has been on the wane. DE is a block cipher that encrypts data in 64-bit blocks. This implies that 64 bits of plain text are fed into DE, which generates 64 bits of ciphertext. Encryption and decryption employ the same algorithm and key, with slight variations. The key is 56 bits long. The figure depicts the core concept. We have mentioned that DE uses a 56-bit key. Actually, the initial key consists of 64 bits. However, before the DE process even starts, every 8th bit of the key is discarded to produce a 56-bit key. That is, bit positions 8, 16, 24, 32, 40, 48, 56, and 64 are discarded.
In the first step, the 64-bit plain text block is handed over to an initial permutation, IP, function. Then second step, the initial permutation is performed on plain text. Next, the initial permutation, IP, produces two halves of the permuted block, saying left plain text, LPT, and right plain text, RPT. Now each LPT and RPT go through 16 rounds of the encryption process. In the end, LPT and RPT are rejoined and a final permutation, FB, is performed on the combined block. The result of this process produces 64-bit ciphertext.
Initial permutation, IP. As we have noted, the initial permutation, IP, happens only once and it happens before the first round. It suggests how the transposition in IP should proceed, as shown in the figure. For example, it says that the IP replaces the first bit of the original plain text block with the 58th bit of the original plain text, the second bit with the 50th bit of the original plain text block, and so on. This is nothing but jugglery of bit positions of the original plain text block. The same rule applies to all the other bit positions shown in the figure.
As we have noted, after IP is done, the resulting 64-bit permuted text block is divided into two half blocks. Each half block consists of 32 bits, and each of the 16 rounds, in turn, consists of the broad level steps outlined in the figure.
Step 1, Key Transformation. Initial 64-bit key is transformed into a 56-bit key by discarding every 8th bit of the initial key. From this, a different 48-bit subkey is generated during each round using a process called key transformation. For this, two halves, each of 28 bits, are divided into two halves and circularly shifted left by 1 or 2 positions, depending on the round. For example, if the round numbers 1, 2, 9, or 16, the shift is done by only 1 position. For other rounds, the circular shift is done by 2 positions. The number of key bits shifted per round is shown in the figure. After an appropriate shift, 48 of the 56 bits are selected. Since the key transformation process involves permutation as well as a selection of a 48-bit subset of the original 56-bit key, it is called compression permutation. Bit 18 is discarded, we will not find it in the table, and like 7 others, reduced to 48 bits. Because of this compression permutation technique, a different subset of key bits is used in each round. That makes DE not easy to crack. Step 2, Expansion permutation. During the expansion permutation, the RPT is expanded from 32 bits to 48 bits. This happens as a 32-bit area is divided into 8 blocks, with each block consisting of 4 bits. Then, each 4-bit block of the previous step is then expanded to a corresponding 6-bit section, and 2 more bits are added per section. The result is a structure called right plain text RPT and left plain text LPT. This process results in expansion as well as a permutation of the input bit while creating output. The key transformation process compresses the 56-bit key to 48 bits. Then the expansion permutation process expands the 32-bit RPT to 48 bits. Now the 48-bit key is XOR with 48-bit RPT and the resulting output is given to the next step, which is the S-box substitution. DE implementation requires a security provider. There are many available providers to choose from, but selecting one is the essential initial step in implementation. It's also essential to test the encryption to make sure it is properly implemented. Now that we have come so far in our understanding of what is DE, let us next look into the reasons to learn DE.